Paste exercise 3L. So I've skipped paste exercise 3K. It's one problem, and I would like for all of you to try that one. Okay. So calculate the tangential velocity vector to the path described by this at the coordinates theta equals pi over 4. Calculate the slope of the velocity vector. So your v will be r prime of theta, your v of theta. So the first component is going to be minus 2 sine theta. That's the derivative of the I component. J component, you're going to have 2 cos theta. Okay, so at theta equals pi over 4, it gives you constants. Minus 1.41 in the I direction, a positive 1.41 in the J direction. So the slope will be v of theta equals to J component divided by I component, giving you minus cot theta. Substituting theta equals pi over 4, you're going to get m equals 1. Number 2, the cardioid shown below can be described in 2 ways. So note the resemblance to a sliced apple. So Cartesian x squared plus y squared, parametric, which is given by this. So calculate an expression for y prime at the coordinates, which is this, using the Cartesian relationship. So differentiating the Cartesian equation, which is this one. Okay, so you're going to get 2x plus 2y y prime. And substituting the coordinates leads to y prime being this. So recall that y prime is the slope of the line tangent to the curve at the coordinate and represents the rate of change in y as x changes. Now calculate the tangential velocity vector at theta equals 3 pi over 4. Determine the gradient of the tangential vector. So you should find that working out r prime of theta will give you this in the I direction and this in the J direction. So at theta equals 3 pi over 4, then you should be able to get these values in the I direction and in the J direction. So the gradient is given by the J component divided by the I component. So you should get this constant. And something to note, that both the Cartesian and parametric equations can be used to determine the slope of the tangent line.